How can something as tiny as a particle be the key to understanding galaxies, gravity, and even whether the universe is expanding at all? In the energy filament theory, particles are not an afterthought you tack onto big cosmology. They are the master key that opens the whole large-scale picture. Because every macro feature of the universe is built from the way these microstructures sit in and reshape an underlying sea of energy. Textbooks quietly dodge this by treating a particle as a structureless point with no length, no width, and no internal details. Then they hang masses, charges, spins, and fields on that point as symbols inside equations. The math can be precise, but you never see what anything actually looks like. You just memorize letters and formulas. Here the starting image changes completely. The universe is not an empty background. It is a stretchy energy sea that can be tightened, warped, and given texture. And a particle is not a lonely dot in that sea but a small piece of it that has been pinched, looped, and knotted into a closed structure. Imagine a huge elastic sheet and a hand that grabs a patch, twists it, ties a loop, and locks it in place. That twisted, tightened patch is a particle. Some particles look like little hoops running steadily in place on the sea's surface. Some look like three tight points linked in a tiny triangular clamp. Others resemble a fine filament wound into a stable knot, both twisted and locked. This season is about giving you a clear mental picture of four basic particle architectures so that electron, quark, or nucleon no longer means just a symbol but a distinct shape and motion in the sea. In that language, mass stops being mysterious. A particle has mass because its structure pulls the nearby sea into a tight dent. The way pressing a fingertip into rubber makes a small well. Push a particle that has carved a deep dent and you are really trying to drag that dent across the sheet, which feels heavy. Electric fields stop being floating arrows and become directional textures. The particle's shape drags the sea's surface into lines that point a certain way. So anything entering that region tends to slide along those lines. Magnetic fields become the same texture seen in motion. When a charged structure moves, it twists its own lines into spirals. Like stirring paint and watching straight streaks curl into swirls. Those swirls are where magnetic effects come from. Everything you usually call field is just the trail of motion left in the sea. The whole season orbits one core job: taking these trails apart and making them vivid. Step by step, we ask questions you may have carried for years. How do particles first appear in the energy sea? What exactly is charged and how is it tied to the fields around it? What is a magnetic field in concrete terms and what actually changes when a charge moves? What are masses and spins beyond symbols, as specific shapes and motion modes in the sea? Then we move to decay. Why some particles are so short-lived while others are effectively immortal. Why the proton can remain stable for cosmic times while a free neutron quietly falls apart. Why quarks seem unable to escape a proton as if trapped in an invisible cage. And how nucleons inside an atomic nucleus can be packed unimaginably tightly as though an unseen grip is holding them together. From there we bridge to chemistry, materials, and life. We asked why electrons do not spiral down into the nucleus but instead sit on specific energy levels. Why those levels allow jumps but not smooth sliding. Why the periodic table contains a limited, discrete set of elements rather than a continuous smear of possibilities. And why different atoms can understand each other's language well enough to form bonds and build complex molecules. Across all of this, the same four ingredients keep showing up: the structural shape of each particle, how tight the energy sea is overall, how the sea's surface texture is laid out around the particles, and how costly it is in tension to change those shapes and textures. Once you look through that lens, questions that used to live in separate courses — mechanics, electromagnetism, quantum, nuclear physics, cosmology — starting to reconnect as different faces of one bottom layer. The only real mental move you need is to set the old point particle picture aside for a while. We are not throwing away its calculations, we are giving you the blueprints they were missing. This season walks you back through the microscopic world from the ground up, starting with the sea itself, then how particles grow out of it, how they read each other's patterns, and how their collective behavior builds the large-scale universe. If you stay with that story, ideas like forces, fields, particles, and cosmic evolution stopped feeling like separate chapters and started to look like one set of habits of the same underlying sea at different scales. Tap follow, share it on New Physics, Clear Universe.